All right. I recently found this problem on Mastodon uh, by this dude, David Radcliffe. And so the problem is basically you have core force, and you can use addition, subtraction, multiplication, and division, uh, and you need to get 45. I mean 42. So yeah, this has been bugging me for a while now. So I thought I would think out aloud and work out this solution. Uh, so initially I tried brute forcing it, right? And I got solutions to 40, 41, 43, 44. So 40 is basically, if I'm not wrong, 8 into 4 plus 8. That is 4 times 4 plus 4. Plus 4 times 1 plus 1, right? Then 41 is basically yeah, 4 plus 1 times 4 plus 1, that is 25, plus 4 times 4, that's 25 plus 16, that's 41. 43 is I forgot how I arrived at 43, but 44 is 4 times 11, I'm thinking. So 4 plus 4 plus 3 times 4. So that's like 4 times 4 times, sorry, 4 plus actually. This is 11 times 4. And this is 44, so you get 43 by doing this entire thing minus 1. Right? But 42 is evading me, and not sure what I need to do to solve this. This is really cool. Like I had so many ideas about this. So 14 times 3, these were all components that I tried to arrive at, like maybe get 14 by somewhere and 3 by somewhere, and then, arrive at the result. 45 minus 3 was something that I had in mind. None of these work because you need something extra. 40 plus 2 is another thing I thought of. None of these work actually. So yeah, what do I do? So one idea that I had was you have 4 major operations, right? You call them plus, subtraction, and multiplication. Okay, in this case, I am not considering division because the only way so if you take these 6 numbers and you pick any 2 and you divide, you're going to be left with one of these choices, right? So if you pick two fours, or yeah, or this, wait, yeah, one of these three choices. If you pick two fours, you get a 1, and you end up with this. You pick a 4 and a 1. You pick a 4 and a 1, what happens? You get 4 and you lose a 1. Right, so you get this. And then you pick a 1 and a 1, you just lose a 1. So all of these have the same elements but with 1 less. So I'm not sure if they're going to be useful, because I mean, if 4 4s and 2 1s did not help me, why would a lesser number of 4s and 1s help me? Is what I was thinking. I could be wrong, but for now I'm not too worried about division. So addition, you could pick two fours, that would give you 16, 4 4 1 1. You could pick a 4 and a 1, that would give you 5. And you could pick wait, what? This is 8. Sorry, I got confused with multiplication over there. Or you could pick two ones, that would give you a 2. Yeah, shouldn't be making these mistakes, but it turns out when I'm talking, make these mistakes more often than when I'm working silently. So, right. Anyway, subtraction, you will have. So let's consider just a 4 and a 1, because you take two 4s or two 1s, you're going to get a 0, and that's not really useful, I don't think. So that would give you 4 4 4 3 and 1. And multiplication, you take two 4s, you're going to get a 16. You take a 4 and a 1, you're just going to lose a 1. You take a 1 and a 1, you're going to lose a 1. So yeah, this is what you have now. Now the idea is take each of these to its logical conclusion. If I'm brute forcing this, I have 5 possibilities. I do the same thing. I do the same kind of analysis for each of these 5 sequences. And yeah, not ideal for sure, but yeah, just couldn't figure it out any other way. How many times will I have to do this? 5, right? The depth of the tree, the max depth of the tree would be 5. Right. So, okay, let me just pick one. Start from right to left and exhaust each option. So 16, 4, 4, 1, and 1. I have addition, subtraction, multiplication. What would division give me here? A 4, a 1. So division be useful here. Let's just have it this time. Just in case. I could always get rid of it later. Make these things bigger. Yep. Way too big. Yeah. What is happening here? So 16 and 4, 24, 1, 1. 16 and 1, 17, 4, 4, 1. Then what? 4 and 4 is 18. So 16, 8, 1, 1. 4 and 5 is, sorry, 4 and 1 is 5. 16, 5, 4, 1. And then you've got 1 and 1, right? So that's 16, 4, 4, 2. Subtraction, similarly, 16 and 4 give you 12. 12, 4, 1, 1. 16 and 1 will give you 15. 15, 4, 4, 1. 4 and 4 is going to give you 0, so that's pointless. 4 and 1 will give you 3. So that would be 16, 4, 3, 1. 1 and 1 will give you 0. So it's not necessary. So multiplication, 64, 4, 1, 1. 16 and 1 would give you the same thing, so it's unnecessary. 4 and 1 would give you the same thing. 4 and 4 would give you 16. Is that okay? Let's just write it down. 4 and 1 would give you 4, 1 and 1 would give 1. So yeah, okay. Division, 16 and 4 would give 4, 4, 1, 1. Already don't see what's the point of division. 16, 4, 4, 4, 4, 1, 1, 1. Yeah, I don't really see the point of division. I'm just going to get rid of it. Okay, can I actually now look at this problem and try and figure out if anything can be done? If I consider this sequence, what would it give me? 17 plus 17, 34. What about 18? No. 16 times 2, 32, and 16, 48. No. So the reason I'm checking here is because I have an intuition that these two sequences are useless. They're not gonna give us the final answer, is what I'm thinking. So 16, 16, 1 and 1. I mean, what could you possibly get from that? 16, 15. Yeah, I don't see anything useful coming out of that sequence, nor from the sequence above. So what just happened? Give me a second. Okay, my headset randomly disconnected. Hmm. 17 times 3 is 51, and I need a 9. Nah, that's not happening. Oh, wait. No. Thought I had it. Hmm. Yeah, thought I had it. Mm. 51 minus 9 was what I was going for, but I, yeah, I don't. I just have a 4 after I use up 17, 4, and 1. 16. This is deceptively simple. I have a 17 and a 9. What's the point? I need a 17, a 3, and a 9. Right. I mean, I'm pretty sure that this one and this one have nothing to do with the solution. Very sure about that. Looking at subtraction and wondering what I could make out of that. But again, not seeing anything, to be honest. 15, 16. Hmm. What else is there? I'm not sure if any of these have a solution. A rational being, we could have found out by now if The only thing I'm scared of at this point, if it's like somehow division is involved, that would be just horrible, wouldn't it? 4, 4, 4, 1 and 1. 8 times 6, 48, minus 4. Yeah, that's another way to get 44. This is 8 times 6, minus 4. There is another 4 left out here. Eight times 5. No, this is 4. Wait up. Not entirely accurate. Yeah, now it is. 8 times 5. Then I have a 4 and a 1 to get 43. Yeah, like I said, I get every single number except 42. I think I even get 39 somehow by 30 times 3. So that would be 4 plus 4 plus 4 plus 1 times 4 minus 1. And then 45 would be 4 plus 4 plus 1 times 4 plus 1. 9 times 5. And there's another 4 here, and you could get back 41 by subtracting 4 from this. So 5. Could I get 46? It's a good question. Could I get 46? Probably not. Can't seem to get 38 as well, at least on the top of my head. What would 38 be? 40 minus 2. 19 times 2. Yeah, 38 is 5 times 8. Oh, no, it's not possible. You'll need an additional one. So is there something about numbers like 38? So right now I can't think of 38. Let me put it up in a different color. Does this even show up? Yeah, kind of. Great. Let me choose blue instead. So I can't do 38, can't do 42, can't do 46. I mean, I see the pattern. They're separated by 4. Can I do 37 then? Can I do 37 then? Yeah, 37. I think it's just 9 times 4, 36 plus 1. And what would 47 be? 12 times 4 minus 1. Okay, so wait, what? So 46 is 4 plus 4 plus 4 times 4. 12 times 4, 48 minus 1 minus 1. Oh, so I can get 46. If I had another 4, if only I had another 4. Fourteen times 3. Why did that not work out? 4 plus, we need a 2, right? Yeah, this is just no clue what's going on here. It's completely lost. I hope I did not misunderstand the question because that would be an unnecessary waste of time. And I hope to prove by drawing out this tree that it was either possible or not. But I don't know. Kind of seems futile to go through all these permutations. How many possibilities are there? What is this? 62? That 15, right? Nah, this okay. 16 ways you could put the numbers down, but considering parentheses and operators and stuff, seems like a nightmare. No, this is definitely not the way. I would feel really stupid if division were involved. Right. Shall we just head to the next sequence and just, yeah, just work it out? Would this be 44431? I don't have high hopes for this. Like, absolutely no high hopes. This time I'm just not even going to go to division. Like, why get fractions on purpose? So 8, 4, 3, 1, or 7, 4, 4, 1, or 5, 4, 4, 3. What else? 3 and 1 would give 4, 4, 4, and 4. This is definitely not the answer. I know that this is not possible because there's this thing called the 4-force theorem. You folks can look it up. It's like, using just 4-force and the basic operations, how long can you go? I think the record is like 10 or 20 or something. Not sure you can go past 20. You can obviously get bigger numbers, but as in consecutively, right from 1. Yeah, 20. So you do 4 times 4, 4 times 5, right? Plus 4 by 4. This is 4 times 5, this is 20. So I think you can get up to 20, or probably much lesser. I don't remember, but there is a theorem like that. It's called the 4-force theorem. So this is definitely not the answer. Subtraction. How did I get here? I got here via. Okay, so yeah, another subtraction. 0, no chance. 4, 4. 3. Wait. Systematically. Nah, this also shouldn't be the answer. So I'm just going to not write it. 4 and 4, no. 4 and 3, no. 4 and 1 is just get rid of the 1 and the 4. You would get 4, 4, 3, 3. Again, I don't think 4433 is the answer. So yeah, I don't think you can do anything with that. I'm just going to keep it because it's not trivial. Right, and you obviously have 4, 4, 4, 2. Yep. Multiplication 16, 4, 3, 1, which is this again, right? So this is like, how are these? Right. So you could, this is not exactly a tree, but like a graph. Makes it much harder. Makes it much harder. All right. Then what would you have? 4 and 3 would give you 12. 4, 4, 1. I think this has also been seen before. Okay, 12, 4, 1, 1 has been seen. Then 4 and 1 would just give you 4. So not writing that. Or do I? I mean, my point is how could it be useful when you have one less number, right? All right. Same with 3 and 1. You just lose the 1 for nothing. Now, do I think these can amount to anything? So 48 minus 5 from this 16 times 3 minus 5, 16 times 3 minus 4 give you 44 and 43 respectively. 16 times 3 minus 3, 45. I got a 43, a 44, a 45, but no 42. Twelve times 4. These two are the same things. 16 times 4. Just don't see it again. Just honestly don't see it. No. Uh, right. At this moment, I'm oscillating between uh, these two branches of thought, where one side I'm just trying to brute force it, and on the other, I'm trying to think through the options. Seven times 5, 35. Anything with 7 is not a good idea because you would need another 7 at the end of it. And to make a 7, you've already used a 4, two fours and a 1. That's like half of what you have. So just making that concrete here, 48 would be 4 plus 4 plus 4 times 4. 49 would be, you could get 49 in many ways, but plus 1 is one way. You could get 50. times 4 plus 1 plus 1. Still don't have 38. Do I have 1? I have 0. I do have 1. I have 2. Do I have 3? How did I get 3? This is 2. Okay, I got 3. I do plus 1 minus 4 plus 4. Right, so I got 3. Now let me just Google 4 fours and see what the there's a Wikipedia page for this thing. 4 fours is a mathematical puzzle, the goal of which is to find the simplest mathematical expression for every whole number from 0 to some maximum. Rules. But these people use concat, square root and stuff. I don't want all that stuff. So until 9, they've gotten. Wow, the Wikipedia solution stops at 32, at which point they've given. The Wikipedia says even 10 is not possible. I mean, just with the basic operations. Yeah, 10 is not possible. Makes sense that because you'd need a 2 somewhere to get a 10, right? So makes sense. But we could get 10 because we have 2 additional ones. So 10 would be 4 by 4 getting 1 plus 4 getting 9 plus 1 10 plus 1 11. 12 is done too, 13 is done, 14 is done, 17 is until 17, 19, 20, 21, 22. We have 23, we have 25, we have 26. So okay, so 26 is 24 plus 2, and you get 24 by doing 16 plus 4 plus 4, right? So 4 times 4 plus 4 plus 4 plus 1 plus 1, you get 26. So we have 26. We have 30 as well, which is 32 minus 2. I could just write 34. So 4 times 4 plus 4 times 4. Okay, so we have every number until 34. How would you get 35? Maybe that's what I should look at. Go one by one. $35 is 7 times 5, so 4 plus 4. Yes. 4 times 4 minus 1, which is 7, times 4 plus 1. So I have 35. What would 36 be? Okay. The reason I got so quiet is because I got into the Wikipedia rabbit hole looking at the references on the article to see if anyone has solved more than what's on the wiki page. It's all I mean, there are tables, but they all have uh, other operators apart from the basic ones. So 32 has 4 times 8. 36 has 4 times 8 plus 4. So we have 38. 4 times. This is 32. Plus 4 is 36. So 38 would be 4 times 4 plus 4. Right? 4 times 8, 32, 36, 37, 38. Right, so we even have 38. I have every number until 50 except 42. I'm just thinking that's not possible, to be honest. Ah. T6 is there. No, I mean every subsequent solution uses factorials. So yeah, not looking good at the moment. So there is a page that has solutions until what? Yeah, check this out. There's a solution to infinity. Yeah, and guess what? The answer is uh, that doesn't certainly help me, but that was funny. Okay, so there's a solution. I don't know consecutively how many numbers, but there are solutions to numbers like 9,370,240. Wow, I mean, this page is really well done. It's, how do I write it? Yeah. Hmm. Uh, Apparently, there's a game called the Four Force game. Nope. Yeah, I'm just surfing the web to find an answer for this. But everywhere I see it's factorial or something of the sort. Mhm. Right. So 42 has many solutions if you consider operations like square roots and factorials. But that's not what we're going for, right? Well, think that's enough for a day. Uh, yeah, super disappointed I didn't get it, but it is what it is. Right. I hope I find out the answer somehow. I'm gonna ask David to tell me what the answer is if if I can't figure it out by myself. Anyway, that's that.